Right, so the first question here, okay, from the information that was given, okay, you must think of all the information they gave you, okay? They gave you that DC is equal to BC, okay? But the important thing here is they told you that AG is a diameter. That's very important, okay? So what you look out for, and then they told you that ADC is a tangent. So when you get a Euclidean geometry question, the first things you look for is, do I have diameters? Okay, do I have a diameter? Why? Because if I have a diameter, then I know this angle is 90 and that angle is 90. Okay, from the diameter to the circumference is always 90. So then you can put that in if you want to. What you also know is that when you have a tangent, okay, you can use the tangent chord theorem. Okay, so you look for those two things. Do I have tangents? Yes, I have a tangent. And do I have a diameter? Okay, that's the most important things to look out for. And do I have the center of the circle? Because then I can put in the radii for those two, for instance. Then I already know A2 is equal to F3. I know that this is 90, that is 90. And I know that D1 is equal to X. You can also put that in. You can say, well, because I have the tangent and I've got a chord DG, I can already say this angle will be equal to X. And like I said, you can put in 90 degrees there. You can put in 90 degrees there. Okay, just because of what they gave you, you can put in those little information. Okay, so now we're going to ask ourselves, how are we going to prove that ADCB is a cyclic quadrilateral? Okay, so one of the options is showing that the exterior angle, if you look at ADCB, one line is extended. So if you can show that D3 is equal to B1 plus B2, if you can show that. So let's say we make this red and we say, that's one of the options, to try to show that. Okay, maybe we can do that. Another option is to try to show that the opposite angles adds up to 180, supplementary. So if I can show that this angle plus that one is 180, or if I can show that this angle plus that one is 180, then I can say it must be a cyclic quadrilateral. The other option is to say, if I can show that from one chord you get equal angles, the chord subtends equal angles. So if I can show that A1 is equal to B1, or if I start here and I can show that D1 is equal to A2, or if I start here, B2 from there, B2, and this way C1 is equal. Or if I start there, and I can show that this angle is equal to that angle. So that looks like an option from chord AB. D2 already is 90. Can we show that from AB, C2 is 90? Not sure, that might be a bit of work. So let's wait with that one. Let's look at the first thing we put in. Chord DC, tangent DC, chord DG. We said that must be X, okay? Because it's the tangent DC and it's the chord DG. So we know this one must be X. But then you can ask yourself, why did they tell me that these two sides are equal? If they are equal, it means this triangle here, BCB, is an isosceles triangle. So I can say, well, by just looking, without doing anything, by just looking at the information I have, I already said that this angle is equal to this one, because it's tangent DC and it's chord DG. But I can also say that this angle is equal to X, okay, because of the isosceles triangle. So then I actually already proved it's a cyclic quadrilateral, okay, because DC subtends equal angles, the chord subtends equal angles. So now you just put in the information. You say, okay, well, first of all, I can say that D1 is equal to X, okay. By reason, tangent DC and chord DG. Chord DG. Okay, so I got X for this one. And then I can say that D1 is equal to X, okay, because that one and that one is equal, because of the equal sides. Equal chords or equal sides. Okay, Okay, gives equal angles. Okay, equal sides, equal angles. Okay, in the triangle. So therefore we can say that ADCB is a cyclic quadrilateral. Just CQ for cyclic quadrilateral. And our reason for making our conclusion is because the chord subtends equal angles. Okay, let's just write it here at the bottom. Chord, you name it, chord DC subtends equal angles. Okay. Alright, is that fine? Or you can say here for your reason, angles opposite equal sides. Maybe it's better to write it like that. Angles, just say here, angles opposite equal sides. Okay, so there we got the proof for ADCB.